All right, so identifying angles. This is what we're going to work on. We're going to work on identifying them, measuring them, and drawing them all together. So first thing we must know is what is an angle. What's the definition for an angle, Kayla?
Based upon
What?
formed by intersection.
So when two rays intersect, when they meet up and cross each other, they form an angle. Pretty cool, right? And what is a ray, Dustin? Anybody remember what a ray is? KDB?
That's a line that's not going directly down the middle. Like, as in radius or
No.
not
Max?
It's a line going in one direction.
One direction, has an endpoint and goes in one direction. That's a ray. And how do we label a ray, Cameron?
What do you mean? Just a line in the ace point.
What is the symbol we use to? What's the symbol we use to say it's a ray? Anybody? Kayla.
a line with an arrow.
A single arrowed line. All right. So when we look at measuring angles, we base it upon a circle. And a circle has 360 degrees. That's why when Evan's driving, you need to be careful because he flips 360s a lot. He's not a very good driver. How many of you have ever heard of flipping a 360? That just means you went in a complete circle, right? The way you started is the way you ended. So when we measure in degrees. Those degrees are not Celsius or Fahrenheit. They're just simply degrees so that you don't get confused. So if we're measuring half of a circle, how many degrees are in it? Haley?
I don't know.
What was the question?
I don't know.
Why? So we're not going to talk and we're going to start paying attention. Connie, do you know it?
I have a question.
What was the question?
What is the half of a circle?
Okay, so how many degrees are in half of a circle?
180.
And we call that a straight line.
Yes.
So if we have an angle of 180 degrees, what do we have? What, Dustin? No. If we have an angle that measures 180 degrees, what do we have? Caitlin? A straight line. Everyone understand that? If you divide that in half, you would have a right angle, and a right angle measures what, Evan? What? 90 degrees. Okay? So do you see how it's kind of broken into a full circle, 360 degrees, half a circle, 180 degrees, half of a straight line is 90 degrees. That's how we're going to identify angles and measure them. With that, let's see if I can get this all on the paper. We have to be able to classify them. So, angles are classified by the number of degrees contained in them. The first one is an acute angle. It is less than a right angle, and its degrees fall between 0 and 90. And I don't really like the word 90 up there, but this is what the book says. I would prefer it say 0 and 89. Because when you get to 90, you now have a right angle. So, for me, purpose, this makes better sense to say 89 degrees. So if it's 0 to 89 degrees, it's an acute angle, and this is what an acute angle looks like. Okay. The next one is a right angle, and as Evan told us, when we have a right angle, it measures 90 degrees. Nothing else but 90 degrees. And what it is two rays that are perpendicular. Here's an example of a right angle. And the really cool thing is if you ever see something labeled, it will have a square to show that it's a right angle. An obtuse angle is larger than a right angle but smaller than a straight line. So its degrees fall between, I would say, 91 degrees and 179 degrees. So anything measured 91 to 179 would be obtuse. And here is an obtuse angle. As Caitlin told us, if it measures 180 degrees, it is a straight line. Which also means that it goes directly out forever and ever both ways. Now a reflex angle is larger than a straight line. So its degrees are going to fall between 181 and 359. Because if it gets to 360, it would no longer be an angle, it would be a circle. And here's an obtuse angle. A reflex angle. Sorry. And a reflex angle goes below the straight line. Okay? So when they have this part right here, they're telling you that's what they want you to measure. That's what they want you to identify as the angle. This part. Now, if it was in here, it would be different. But it's out here is where they want you to measure. So if I'm writing this down, I'm writing acute, 0 to 89, right, 90, obtuse, 91 to 179, straight, 180, and reflex, 181 to 359. This is also on the website and in the Business Lab folder, and all you have to do is hit print. Alright, so measuring and constructing angles. Yesterday I told you to do a little homework and tell me what you found out in just a second, okay? The size of an angle is not affected by the length of the rays. The length of the rays are endless. They can go on and on and on, and it doesn't matter how far they go out. It does not affect your angle. The same number of degrees would be in the angle no matter how long the ray is, because the angle is measured at the beginning, at the vertex of the ray, or the vertex of the angle, so the end point of each ray. And Kelly, can you tell us what we use to measure an angle? What? Say it loud. A protractor. And Caitlin said yesterday it's a half of a circle, and that's correct. It's a semicircle, and it has markings in degrees along the edge. Here is a protractor. So we have degrees marked from 0 to 180 all the way around. We have two sides to it. You have an inside and an outside, and we'll get to what those measure. This protractor also has with it a ruler, so that you can measure straight lines and what the straight line is. So a protractor is what we use to measure our angles.
Please have to get one of those.
Nope, we have a ton.
We have a ton of them.
All right, so using a protractor, this is always that. I'm not sure how to use it, Mrs. Miller, so can you help me? And that's what I'm going to do. I'm going to help you, hopefully. Alright, so using the protractor, first thing you want to do is place the center mark on the vertex of the angle. Haley, where's the vertex? No, there's an actual spot that's the vertex. Anyone want to tell me? Max?
Where the two lines lines collide.
Where the two what?
Where the two rays.
Where the two rays connect. So right here is my vertex. So I'm going to place the center of my protractor on the vertex. The really cool thing is most of the time it has a little hole, and if you have your pencil, you can put your pencil on the vertex to hold it there. Okay? Then you're going to make sure the ray, the first ray, and I call this one the first ray, runs along the baseline. That would mean it hits at 0. This is kind of hard to see, but hopefully you're understanding. So does everyone see how it's hitting at 0 there? Then make sure that the second ray crosses through the scale. Sometimes your angles are going to be small. Your rays will be shorter than the protractor. Make sure you draw it out far enough that it goes through. Then you're going to read the number that the second ray passes through. The outside, 0 through 180, so this set of numbers right here, is when the ray extends to the left of the to the right. Oh. I think I have that wrong. Right, left. Extends to the right of the vertex is this one.
That's for acute angles, right?
Yes. So in mine, can you see it or not? Is it really bad?
It's kind of dark. Get an idea.
Is that better?
That's way better.
All right, so we have the first ray on the 0. The vertex is in the little dot here, and the second ray comes up. So the second ray passes through. Here's 30, 31, 32, and 33. So I would label my angle as 33 degrees. Okay? If we had points on these angles, A, B, and C, we would list this as angle CAB equals 33 degrees. Okay, because remember when we label an angle, we always make sure this letter remains in the middle. We could have also labeled it angle A equals 33 degrees, or angle BAC equals 33 degrees. Questions? None?